Good morning. Good morning, everybody. This is Engineer Suraj Singh. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, August 3rd, 2021, Tuesday. One more day of life and one more day of year. And talk continues as usual in relation to quality and quantity and safety. I am adding quantity because quantity goes along with quality. That's why quality and quantity are both important. None of these can go alone. That's why I'm saying. Title of talk is Civil Field Engineering, Quality AnnexSL, COVID-19 and SHE both related in engineer's role and in public role, designs, construction methods, organizations, contracts, etc., etc., quality on top, safety on top, and then general considerations, and particularly is targeted to those who are very well educated and competent, having certificates of different types. They may be professionals of given competency. They must work accordingly. That is meaning of certification. It's not simply that I have a certificate, I think I am everything. Your product, your performance must tell your certificate is there. Your certificate should not tell you will perform, but you should perform, that's required. Well, my thinking is a little different. I value certificate not because someone has given me. This certificate means I have achieved it based on my efforts and based on performance in studies and in work, because these are educational as well as competency certificates, and competency comes only when you perform. And if you perform means it is seen by everybody, it is experienced by everybody, and these certificates are nothing but just a kind of verification and corroboration that yes, you have that competency, but that competency must be seen in your work culture and work both. And if it misses there, I can say something is wrong somewhere. Well, my purpose is just to have a glimpse on means what is use of this competency, what's use of these certificates. These certificates do not dictate personal, individual, but individual it tells others. Individual tells others that what I am. These certificates means I can work successfully, proficiently, promptly, with a mark of target, and you can say milestones, definitions can be upheld, goals can be achieved, but it's not easy. It's not easy. It is hard work, smart work, intelligent work. I am saying hard work because everything cannot move in shortcut. You cannot say you are smart because you know every method how to do an easiest way, best work. Every work cannot be done easiest way, just like a human body cannot be developed in an easiest way. It takes defined time. A human body cannot be developed in 3 days. It cannot be developed in 9 days. It cannot be developed 9 weeks. And it doesn't require 9 years. It requires only 9 months, which cannot be changed. And if it is changed, means there shall be some problem with that product, human body. Get my point what I am saying? Every work, every performance, every target can be fixed based upon some observations, based upon some natural observations, human observations, work observations. Quality cannot be defined in one line. Quality cannot be defined in one line. And safety, health, and environment can also not be defined in one line. These vary from action to action, from result to result, from proposal to proposal. We say quality in general and also we say safety in general, but in fact, these are both competent words, terms, and this must require competent people, consistent people, dedicated people, occupied people, devoted people. If you don't have these properties in some individual, you can't expect results, pertinent quality and safety, health and environment. Just sitting in chair and thinking you can do everything, I think that is delusion and illusion. You cannot do that. Work means physical action plus mental action plus experience. Experience teaches us where I did wrong, where we did wrong, why did we wrong. We have certain lessons from past that teaches us in present that we made mistake there, we should not mistake here. That is based on lessons learned. Because I am talking of production, manufacturing, construction, because these are only current economic criteria that can lead world. Without these, world shall stop if there is no development, there is no economy, there is no production. Every act, every action shall stop. 95% of our work, our life is dependent on physical economy. And physical economy means quantity of every material, quantity of every service, quantity when I say this means a type of magnitude. That magnitude is defined in our physics. It should have some quantity based and direction as well as quantity and direction, in what direction we have to move. It can't be free, it has to be defined. Quality definition is innovative. Every day you can think of and you can define. But in principle, it is already defined by itself. Because we cannot say quality without material. Whatever material we use, whatever resources we use for quantity production, which means quality production, without those resources and sources and ourselves, quality doesn't exist, because quality means existence of quantity. There are hundreds of materials, thousands of materials in nature that we consume, we extract from nature, from earth, from crust of earth. We extract those materials in terms of ores and later processing for extraction of minerals, or directly we take from rocks. From rocks we take materials, different types of physical materials, different types of minerals, and we extract elements, metals from these components of rocks. Chemistry exists there for purpose of mineralogy, and there's, we can say, great science we can go through. But here I'm not talking of that. I'm interested in just expression of quality. Everybody has different understanding and different reference and different relation. That's true, because classification of quality is of immense importance. Classification is one part, and we can say production is also another part. Where do we suffer? Because material we receive, raw material, natural material that we receive, it is whatever quality it's having, it has. If we can alter its property, practically we do it. But if we can't alter those properties, beyond our limit it is, then we use whatever it is in nature after experimenting, after testing, after knowing properties of that. And that is beyond our controls. So quantity is beyond our control sometimes because we have to use it. It may be mechanical world, electrical world, other world, civil world. Metals are used, rocks are used, water is used, steel is used, or you can say metal is used everywhere. Steel has some control, is given us some control because we cannot extract steel in product form. It has to be extracted out in original form, natural form. Rocks can be crushed only or screened, but cannot be done otherwise except washing. Same way sand, and also water can be purified to some extent to meet construction defined purpose. Likewise, we say every work in mechanical world is also very big. Mechanical world linked to electronics, linked to electrical, because mechanical world is not isolated as well. If you want a machine has components which are material components, metallic components, plastic components, and also electrical circuits within this. And electrical means electronic circuit within this. Digital machines, digital operations. So you can say in one product there are so many inputs from different branches of engineering, just like civil has all inputs from electrical, mechanical, electronics. Likewise, mechanical, electrical world, electromechanical world. Electromechanical world is so vast nowadays, like civil, that no plant is possible to be established, to be, you can say, constructed. No plant facility is possible. And when I talk of plant, it doesn't mean small machine. It means very big plant, like powerhouse, like you can say refinery, or you can say onshore project or offshore project. Wherever you can see, you'll find machines, of course advanced level machines. Even for excavation we use machines. Excavation is one activity which was done long back by manual work, and now it is done through machines, heavy machines. That is, you can say, you have augmented quantity work. How many cubic meter we can excavate in a day, that criteria has gone up. In past time we used to say how much one person can excavate in a day, but now it's excavator we have, backhoe we have. We can excavate like mass work, but it doesn't affect quality because excavation is excavation, except that we have to be careful that existing services are not broken and suitable machine is available. Its disposal also is very important, that I should keep in mind while doing excavation work, that environment is not impacted upon adversely. There's so many points we have to consider. Quality is that, means whatever activity we have to do in whatever engineering branch, though actually in fact generally all engineering is done interactively these days. If I have to excavate, I can say excavation is a civil work, but machine is required. This means it's mechanical support. Without machine, I cannot excavate in short term or in my program allowance of time. I cannot do so. Here domination is machine. If I don't have excavator, there is no meaning of anything for excavation. I can't excavate. If I have water table near ground, I have to dewater that portion, that volume we have to excavate. Then pumping is required, well point system is required, or whatever way, whatever system we have to adopt for dewatering, that's required. So mechanical input comes in, and when mechanical inputs come in, automatically electrical inputs would also come in, or you can say fuel input like diesel, petrol or CNG would come in. Somewhere you can say electrical part is important, somewhere mechanical part is important. You cannot say that exclusive branch of engineering is engaged. And same way, this I said, when you have to do survey work, before even excavation, you have to establish your relative marks, relative references like coordinates and northing, easting, and you have to control horizontal flow, horizontal and vertical references, levels and coordinates in 3 dimensions, 3 directions. Then you can say your electronic instruments come into play, dumpy level comes into play, theodolite comes into play, distomat comes into play. Likewise you can say grid system, GPS comes into play. Means electronic is also involved there, without which you cannot move. This means allied engineering, you can say, when I say field engineering, civil field engineering, it doesn't mean civil engineering field, this means total field engineering, total engineering. Means we have to consider, we have to analyze all these factors. This is quality system, you can say all is quality system, because everywhere certain level of quality requirement exists. Accuracy also quality it is, how much accuracy we are doing. We say, oh, this is tolerable. That's a part of quality system. If we do not comply with that, we can say we have gone beyond controls. We can't control like this. Means quality therefore is having a definition. You can say whatever is prescribed, whatever I design, my design has limits. It's not my limit, this is conventional limit, this is coded limit, or this is established conventional limit, where we can say it's safe, it doesn't go beyond our controls. If we can control it and it works well and is accepted as a part of quality system and quality, then you can say it's quality work. Means we have a silver lining that we have to stay within this control, and for that work, that's quality definition. Quality can be defined for every person, for every machine, for every instrument, for every physical work. When we say temperature, we measure, use certain mercury thermometer and say this is temperature, and that temperature is in relation to some mercury material. We also say that this is okay, this is error in this error is tolerable, we can adjust this error, and errors are adjusted in all instruments, in all works. That's also a quality control, you can say quality tolerance. This quality, if within this we achieve, it's okay. I'm trying to explain to you because everywhere there is some error. Just like you can say a train runs on railway track. Maybe you've never heard this. A train runs on a railway track, and railway track has a design. These tracks are inclined. Maybe you don't know. Not horizontal exactly. And there's some jump. There's some jump on high-speed trains. When train runs beyond 60, 70, 80, it has little jump, minor jump, you can say in millimeters, few millimeters, and that jump means weight of train is reduced while running, and there's certain definition that within this speed it can jump up this level and not beyond that. Likewise, you can say that's also a kind of system we define, or you may say it's kind of working specification, which is called definition of quality. Definition of quality can be said that its specification on this up to within this description of specification you can go through this. Therefore, don't be scared of quality. Quality is not miracle, it's a part of life, and if you don't understand this point, you can never understand quality. And not only this, you cannot understand yourself. A body is also a quality body. Physical, how strong we are, what's my strength, what's my equilibrium system, what's my blood pressure, what's my strength in body, what's my mental capacity, how many hours can I work without tiredness, without fatigue, or how much I should eat. Everything is defined in medical world, and that's also a kind of observation based, comfort based. If you are happy, you are feeling okay, healthy, you can say yes, I am healthy. This means you can maintain your health, and then you can work also even if you're not healthy. That's called quality of a person. You say quality of this person is very good. This person can do this and that, and this person is reliable. Reliability factor is very important. Reliability factor is very important in our world, because if you want to use some person, some machine, something, it's not going to be used once only. It has to be manufactured first, and it has to be used thousands times, maybe lakhs times during its life. Every small equipment or every big equipment, both have certain destinies, certain performance time. Just like we have a body, I have a body and I don't know how many years I have to live, but God knows that, system knows that. My life longevity is this. How many years I have to live? Same way, machine, how many years it has to work, or a bus, how many years it can run. Every equipment, every machine, every, you can say, tool has certain life. That life it must do demanded performance, expected performance. And if it does well, satisfactorily, up to that level, we can say yes, this item, this good, or this object is reliable, which means it can work safely, it is safe, it can perform, and it is efficient, and it is, you can say, serviceable. We can get service. Everybody can remain safe if you use this, and this also should remain safe and shall work its entire life, which you expect from this. Of course, due maintenance is required, service is required, but we can say whatever we consider the object is qualitative, you can say it is reliable. That's the purpose of that, that's the meaning of that. Profession is not easy, or you can say it is intellectually oriented. When we say not easy, means it's not that it's impossible. It means that it requires a level of thinking, and to perform it requires a level of a criteria of competency, that you must understand whatever you have to do first. And if you don't understand and you do it, there's no meaning, because you will make mistakes without understanding. There's a difference in intellectualism and in delusion. Intellectual person is real one. Intellectualism requires analysis, it requires complete knowledge of that, pre-knowledge of doing that work. It requires some input from your base, from your education, or from your references, and then you apply your intellectualism on that. Otherwise, it's illusory work, it is imaginary work, it's no work. When you use intellectual power to do something, it's called brilliant work, and that work comes under category of profession. Profession means use of mind. Profession means understand reality. Profession means understand facts, know facts. Profession means no illusion. Profession means apply resources, use resources. Profession means Understand what you have to achieve. Profession means no waste of time. Profession means tolerance. Profession means output. Profession means input. Means all whatever I am saying, this very small list, there's going to be long list as well, but there's the meaning of defining as this days. Because professional means expertise. Actual meaning of profession is expertise, specialty, knowing as much as possible before doing some job and learning after making mistakes. If you know as much as possible, there are sure chances that you make little mistake or no mistake. But if you don't have complete experience, you are a learner, you will certainly make mistake once or twice, and then you will say, no, I know how to do it. That is required. Mistakes teach us. But when you are a professional, you say I am a professional, freelancer or independent, this means you are expected to have thorough knowledge of that work and apply that knowledge to produce some good or some product. That's called professional product. But if you miss quality in that, you don't allow that quality is expected, then you are not a professional. You could be a manager, but you are not a professional. I don't consider managers as professionals, because professional means you must have some practical training on what to do. You should understand the specifications. You should understand how this work can be done. You should know every plus and minus of that work. You should know all inputs and outputs of that work. You should know what problems you can face, what risks are involved, what time is there. All these points come under definition of system. When I say system, quality system, this means system that has from A to Z every level of explanation and every record of performance, and it tells you you have to do this or that. Steps are there, processes are there, procedures are there, and it depends upon you how to establish that. A small product or big product doesn't make a difference as far as procedure is concerned. Method is concerned. Method is method. It can be your method, it can be my method, but target remains same, controls remain same. You can say quality remains same. Yes, it can be improved, of course. There is no harm in that. Improvement over expected level of performance is better than nothing, Is better than nothing, you can say. If I say I have improved my performance, well, I think that's best way I can answer something. And that depends upon analysis. Analysis says that you have to understand whatever action you are going to take on whatever item, whatever work, whatever product. You have certain plan for that. And that plan, if you have prepared, that's based on your analytical thinking. You cannot make a plan if you don't understand procedure. If you don't understand what you have to do, what is your requirement, what is your plan, what is your goal, where you have to go from this imaginary point 0 to imaginary point 10. Imaginary because till that time there is no plan. Something moves in your mind, and that movement of your mind, when it comes to paper, maybe it in rough form, you can say it initiates a planning work. You see, experience in profession is far most, you can say, reliable, far more significant than just having theoretical knowledge. I say theoretical knowledge, but theoretical knowledge is also important, very, very important, because theoretical knowledge gets you knowledge about how to do work, and then you can improve that and form your own systematic knowledge. You can devise your own system for your own interest, for your own project, and you can think, and then only you can do. No plan can be charted out, no method can be charted out if you don't have total experience of that. If suppose there are 20 points, 20 requirements in one work, and 2 requirements are also there which you do not understand, then you can't complete that work. Means you have to study all these requirements, why these points are there, are these necessary or not necessary. Then you can either put in more or give out from there and work. Why I am saying this? Because quality is always a question for me. I am not saying that we do not produce quality. We produce quality, but we do not produce quality to total system, total goal we put on. If I produce quality where there is a defective work, or we cannot do work on that, or means this cannot give that efficient service or level of service, or you do not even check and deliver some material without even working. It means non-working material is supplied even. That's nonsense. When you say quality means whatever work you do, whatever production you do, or whatever actions you take, those should be work actions. Those should be real actions. Those should not be imaginary actions. It is very difficult to define really quality, but we can define a system. System becomes a world of quality. It may be ISO 9001, 2015 or other systems, maybe. But I'm not very much, happy that we should be slaves to system. That's also not true. Because it is designer, it is owner, it is professional who all are involved in analyzing, in foreseeing, becoming forevisionary, and to collect all information to one goal, and that is process. How shall we do this? Keeping abreast finances, keeping abreast time value, and keeping abreast future of your work, future of your profession, future of your business, and on top of all, what benefit can consumer or end user draw from this. All this, though it's very easy to talk, I can say refer to this book, and you can say refer to that one, but basics are not clear. And when basics are not clear, you can find always problems. If I do not know counting, if I do not know summing, sum up, how to sum, how to subtract, how to multiply, how to divide, how to do some other under root, cubic root, if I don't know that, and I say, no, I'm going to pass mathematics, I think that is called foolishness. Life is mathematics, to be very frank. Whole life is mathematics, and without mathematics, life cannot move. That's also true. So if you understand mathematics to your requirement, certainly you shall be able to give system quality. When I say system is very wide word. There is no system that is independent. Yes, it may be independent in ownership, it may be independent in some organization, but organization is not independent. It has to depend on other organizations. It has to depend on institutions. It has to depend on government, maybe, or it has to be dependent on someone else. So when dependency factors is very high, then quality cannot be moved in isolation, because we are linked to others. I have to define my process of organization, how I control, and tell others, see what we are operating is this. Other person should be satisfied with that, and then only we can go further. But if we don't care for system, we just write colorful system and say this we can do, that we can do nothing in fact. Look, when we are educated, when you are educated, I mean to say, when you become engineer or doctor or professor or whatever work you do, your education is a system. Education through which you have passed, that's also a system. That system you have to study, only then you can pass. Because your candidate, your student, concessions are given to you. It's given to student, okay, you pass so many percent and we allow you to go move further. This means there also system exists of education It's for all, but not for individuals. And if somebody understands that and studies well to do cover all syllabus and then gets very good marks in answers, is still then that student is not fully perfect. Because life has not taught him, teacher has taught him. Learning books, having education from books is required for purpose of education indeed, but that is just part of system. System in profession has to run, has to move throughout life. It depends how you develop yourself. Quality, when I say, again I say, it's a criteria. It just says what you have to do and that you define yourself, nobody else. If you are a competent person, you have to define yourself what you have to do. That's fact of life. Until something is beyond your control, you have to decide what you have to do. And when a stage comes that something stops you to make a decision, you cannot become decisive on that part, then you have to take help of someone else for completing that project. This is very common because everybody knows nothing, everybody knows everything, but we can say everybody cannot know everything. That's also true. And those who know more than that, we have to consult them. They can be our advisors. They can be our mentors. Quality cannot be defined in 1 minute or one go. I think these days it's not quality fashion, but it's group fashion, and that thing this is quality. Quality doesn't mean group. No, it doesn't mean how many members you have. That's not quality. It's requirement. You have to calculate how many persons you need in an organization for this discipline, for this work, for that work. It's not that you keep 10 persons with me, say I'm running quality. What is job of those people? That's very important to be understood. I don't want to keep redundant staff, and I also do not want to keep deficient staff, because my staff should not be deficient. My resources should not be deficient, because deficiency means loss of time. I don't want to have a reservoir of loss of time, because time is an important factor. It impacts on cost and both impact on quality. If somebody argues that I did not have budget for this quality, I don't accept this statement, because this is nothing but foolishness statement. Some people have a habit of lying. Some people have a habit of showing. We are too busy. You can't be too busy. If you have clear concept and if you have time, you can't say that you are only busy. Problem is that we want to move in haphazard way if you don't have adequate knowledge. And this happens. There are so many levels of education these days that some people don't understand what's best for them. First I do engineering, I'm happy I've done engineering, and person is happy. But what happens that, engineering is not giving me good business, it's not giving good money, so I have to go to management. As a management shall get you rupees from tree, you think so, I'll get this package after passing this degree of management, or some other controls you can say, or you start doing your own work. But whatever you do, again I say, you have to depend on others. You cannot move yourself alone. The smallest company which outsources everything, they too have infrastructure, but without that they can't do anything. That infrastructure you have system, you have to define. And every product manufacturing, every engineering design, every industrial product, all these depend on power of money investment. And after getting that power, how to use that and how to get that power recognized. Recognition doesn't mean that they love you. No. Recognition means that your work is reliable. We want to buy this from you always. That can be one consideration. Or there will be other consideration that these people are very senior and we can use them. But this doesn't happen actually. It doesn't happen. Safety is same way, very important part of life. If I am not safe, I can't work. That's true. How can I work if I am not safe? Well, that point is point of understanding. You can't be safe if you don't care about. If I stand on a parapet and I don't care and fall, nobody can stop me. But I didn't like to fall. Accidentally happens. It applies to everybody. It doesn't apply to me only. It applies to everyone living in this world. It applies to everyone. It's very important. It's very important that we think of quality. It's not important of thinking alone. We have to think for quality target. You see, there are thousands of products in the world. And quality should be there in every product. That is purpose of quality system. Though we say product doesn't guarantee quality, but system is guaranteed. You got my point? I think this is management definition. They say my system is intact. There is nothing wrong in this system. It operates perfectly. But I say I can't guarantee quality of product. Well, I think it's what sort of mathematics it is, I don't understand. What sort of mathematics is? If you claim my system is intact, it performs, but I can't guarantee quality of product. Well, I think there is no link, there is no proportional rotation in this. If your system is intact, everything is intact, you are intact, your product must be quality. This means you are lying. You have not understood your system thoroughly. You have not given thorough input. And you expect quality product and you claim that it is quality product. But it's not. By definition itself it's not. And if a person understands you are a good company, brilliant people, you have a profile, so we can trust you. Remember, when you depend on trust, you always lose. You may be employer or you may be employee. Trust is no professional world. It is a procedure world. It's an opportunity world. If I trust someone, I can say, okay, for timing I trust you. Even if you don't have documentation, you do it, I'll say how can you do it. So it's another kind of observation you have to make with everybody. We know generally that people who come after passing degrees for engineering, they cannot do everything on their own until they learn. And that learning period is a couple of years, and they are like innocent engineers. They have a right to make mistakes. You can't say exactly right means they should understand what they are doing wrong. And in engineering it generally happens. Quality target is very easy if you are sincere, if you have educational background, if you understand what is society, if you understand what is brotherhood, professional brotherhood, and if you understand how to handle others. how to handle others qualitatively, not by might is right. No, not by might is right. Every day I waste your time in talking quality. I take your time. I try to tell method statements are very important. You have to understand them. But I think it is not a part of our culture in profession that we have to define some detailed statement in terms of method before resorting to risks. If our method is reliable, our method is professional, it's in you can say proportion to our schedules, and we can know that now our limit is over, or even medical limit is over if medical says. But you move further for others, not for that organization that time, because that organization retires you. But life doesn't retire you. Life doesn't retire you. That's what I say. If you can understand, even if it's not writing in mind, and you are a supervisor or an engineer, and you can explain to them what you want, don't think they won't give. They will give, because you are new. They would give that answer, and that answer is very, very important. COVID-19, I just bring into my talk every day because it's also very important. Now COVID-19 is part and parcel of our life. We may say whatever we say, but it's a fact. First time in history of Earth, COVID-19 has been very popular. I can say, if there is one celebrity in this world, that's COVID-19. COVID-19 is very important in this world now. We don't know what it is, but we can move here and there. Why? Don't waste time. Don't be confused. Whole world is confused, I know. There is no need of confusion. It's rain, and in rain, what do? You run away. You have umbrella, you use it. Or you have rain overcoat, you wear it. It may be momentarily. It may be 10 minutes, 15 minutes rain, half an hour rain, 1 day rain. And you have protective covers with you. So you can sustain. This protective cover is a part of method statement that if you want to get rid of rain impact, you have to use umbrella, as well as you have to use these overalls. Risk is always there, cost is always there. If you have cost, you have risk, you can reach to that destination. COVID-19, don't take it otherwise. I'm not scientist, I'm not doctor. But I know one answer very easily, that if you want to live safe, if you want to lead your people for 1 year, 2 years, major part of your job can be over. That's what we say, time-based, risk-based, all this conversation. COVID-19 is not new now, but it still is flourishing. It's not able to tell you, it's not able to declare secret, and it's giving every day more and more problems to world. No other way, you have to accept these problems. No other way. Only way is trust whatever you say. You can trust vaccines, you can trust everything, but most important point of trust is protection. Use protective measures even if you are at home. use it, then you will find that these products, when integrated into system of of nature, these products, these, you can say, chain reaction between, for new generation, between two entities is important. Life depends on past experience and future vision. Vision is not seen, it's only imagined. And you feel, yes, I did that, even if there may be spelling error, but I did that. That brings a degree of satisfaction. True specification, we get it. We get that one. Engineering full of secrecies. Secrecies in a sense, not that what I say, engineering is full of applications, and these applications are full of secrets. Important part of engineering is civil designs of structures or design of otherwise. Communication to self is also important. It's not that you have to communicate with others. All points are covered in system, and communication is related to that. What I have to speak, what I have not to speak, that you have to decide before you speak. If we can understand applications, we can understand engineering. Because engineering is nothing but applications, or you can say work. Work is engineering. Direction is engineering. Thinking is engineering. And if we can do that, I think that's best way we can achieve in our work. I'm not saying you stick to that, but move on that. Why quality is falling? It's a question mark to every engineer. I would say engineer because in manufacturing, in industry, in factories and on sites, dominant lead role remains with engineers, with technology, with methods. And if you don't devise this, okay, technology is not in your hand, maybe it's in your hand, but method is in your hand. What organization teaches you, those representation organizations, those do not teach you from their own. These lessons come from various books. So our this skeleton, which we will have later, shall also depend on this aspect. Safety is of paramount importance because it's a question of life and death. Safety, we call it safety is first. This means safety is for paramount importance. Now we'll jump on to, I would simply say for COVID-19 that use masks, keep safe. That's most important answer. Your life is for you, not for others. You have to decide for your life. Don't be a part of mad rush. Never. Then we were discussing last time about safety, and we have gone through, you can say, many you can say if I go home, it was construction hazards. This is page 17, 16 of some book, but I'm just taking this for you people. And we had got introduction, scope of construction, then we got up further on that. Hazards and controls, then safe place of work. Likewise, we went on to some pages. What is demolition, all that. So here, fire and other emergencies. So here, health and safety file we have discussed. Let's take a little glimpse of this. Selection control of contractors. Okay, health and safety file, let's start from here. Health and safety file is a record of relevant information for client or customer. It is developed as construction progresses with various designers or contractors adding information as it becomes available, and files should be useful to clients who have a duty to provide information about their premises to those who carry out work there. Designers during development of further designs or alterations. CDM coordinators preparing for construction work. Principal contractors and contractors prepare to carry out or manage such work. A number of people have legal duties with respect to health and safety. A number of people have legal duties with respect to health and safety. CDM coordinator, that is construction design manager, management coordinator, must prepare, review, amends or add to file as project progresses and give it to client. Contractors and other contractors must supply information necessary for compiling or updating this file. Clients must keep file to assist with future construction work. Everyone providing information should make sure that it is accurate and provided properly. Everyone, client must keep file to assist with future construction work, and everyone providing information should make sure that it is accurate and provided promptly. Client should make sure that CDM coordinator complies with compiles file What is needed should be agreed in advance so that designers and contractors can produce relevant documents as their work progresses. File is key part of information that a client or their successors shall need for future construction projects, and so should be kept up to date after whatever relevant surveys are run. A file must be produced or updated if one already exists as part of all notifiable projects. CDM 2007 allows one file to be maintained for a site and then updated after subsequent projects have been completed. Information which should be included where they are relevant to health and safety of any future construction project. Selection and control of contractors. Important that health and safety factors are considered as well as technical or professional competence when potential contractors are being shortlisted or employed. What happens? Following item shall give a guide to health and safety items. Registration with either HSC or SHE or Environmental Health Department of a local authority, a current health and safety policy, details of work, details of risk assessments made and control measures introduced, method state required to perform contract, details of competence certification, particularly when work with gas or electricity may be involved, details of emergency production, emergency procedure, details of insurance arrangements in force at time of contract, details of emergency procedures including fire precautions for contractor employees. Details of previous accidents or incidents reported under RIDOR. Details of accident reporting procedures. Daily details of previous work undertaken by contractor. References from previous employers or main contractors. Details pertinent health and safety training undertaken by contractor and his employees. On being selected, contractor should be expected to. I'm getting some gastric. I don't know why. Air blocking my. Just a minute, please. Contractors should familiarize themselves with those parts of health and safety plan which affect them and their employees and or subcontractors. Cooperate with principal contractors or main, if not a favorable project, in their health and safety duties to contractors. Comply with their legal health and safety duties. On arrival on site, subcontractors should ensure that they report to site office on arrival on site and report to site leader, abide by site rules, particularly in respect of personal protective equipment. Performance of their work doesn't place others at risk. They are familiar with first aid and accident report and its arrangements of principal contractor. They are familiar with all emergency procedures on site, materials brought on site are safely handled, stored and disposed of in compliance. Matters brought onto site are safely handled, stored, and disposed of in compliance where appropriate with current control of substances hazardous to health regulation. They adopt adequate fire precaution and prevention measures when using equipment which could cause fires. I'm sorry, some problem in my stomach. Don't mind it otherwise. They minimize noise and vibration produced by their equipment and activities, and ladders, scaffolds, and other means of access are erected in conformance with good working practice and work at height regulations. Welding or burning equipment brought onto site in safe operating conditions and used safely with a suitable fire extinguisher to hand. Lifting equipment brought onto site complies with current lifting operations and lifting equipment regulations. Electrical equipment complies with current electricity at work regulations. Connections to electricity supplies from a point specified by principal contractor and is by proper cables and connectors. For outside construction work, only 110 volt equipment should be used, or in our country 240 it is, and restricted access to areas on site is observed. Welfare facilities provided on site are treated with respect. Vehicles brought onto site observe speed, condition, or parking restriction. Control of subcontractors can be exercised by monitoring them against criteria listed above and by work should be checked to ensure that agreed standard has been reached and that waste material has been removed from site. Working above ground level or where there is risk of falling, hazards and controls associated with working above ground. Significance of injuries resulting from falls from height, such as fatalities and other major injuries, have been dealt with earlier and has been important legal requirements for head protection. Also covered with many hazards involved in working at height, including fragile roofs and deterioration of materials, unprotected edges and falling materials. Additional hazards include weather and unstable or poorly maintained access equipment such as ladders and various types of scaffolds. Principal means of preventing falls of people or materials includes use of fencing, guardrails, toe boards, working platforms, access boards, ladder hoops, safety nets and safety harnesses arrest fall by restricting fall to a given distance due to fixing of harness to a point on an adjacent you can see this adjacent ladder should be adjacent. Let's be correctly fixing ladder, okay? Adjacent rigid structure. They should only be used when all other possibilities are not practicable. There are many different types of access equipment but only following four categories to be considered: ladders, fixed scaffold, prefabricated mobile scaffold towers, mobile elevated work platforms. Ladders, main cause of accidents involving ladders is ladder movement while in use. This occurs when they have not been secured to a fixed point, particularly at foot. Other causes include overreaching by workers, slipping on a rung, ladder defects, and in case of metal, ladders contact with electricity. Main types of accidents are falls from ladders. There are three common materials used in construction of ladders: aluminum, timber, and glass fiber. Aluminum ladders have advantage of being light but should not be used in high winds or near live electricity. Timber ladders need regular inspection for damage and should not be painted since this could hide cracks. Glass fiber ladders can be used with near electrical equipment and in food processing areas. Following factors should be considered when using ladders. I'll be back within minutes, and meanwhile you can go through some. Okay, here we are back. Now I like to take, we can say that you are interested in this, that we are talking of ladders. And I think we thought that there are three common materials used in construction of ladders: aluminum, timber, and glass fiber. Aluminum ladders have advantage of being light, but should not be used in high winds or near live electricity. Timber ladders need regular inspection for damage and should not be painted, since this could hide cracks. Glass fiber ladders can be used with near electrical equipment and in food processing areas. Following factors should be considered while using ladders. Ensure that use of a ladder is safest means of access given work to be done and height to be climbed. Location itself needs to be checked. Supporting wall and supporting ground surface should be dry and slip free. Extra care shall be needed if area is busy with pedestrians or vehicles. Ladder needs to be stable in use, means that inclination should be as nearly as possible 1:4 ratio of distance from wall to distance up to wall. Foot of ladder should be tied to rigid support. Weather conditions must be suitable. No high winds or heavy rain. Proximity of live electricity should also be checked. This last point is important when ladders are to be carried beneath power lines. This should be at least 1 meter ladder above stepping off point. Work activity must be considered in detail. Overreaching must be eliminated and consideration given to storage of up ladder. Ladder must be matched to work required. Workers who are to use ladder must be trained in correct method of use and selection. Such training should include use of both hands during climbing. Clean non-slippery footwear, clean rungs and an undamaged ladder. Ladder should be inspected particularly for damage or misused rungs and maintained in a regular basis, and they should only be repaired by competent persons. Transportation can occur at these times. They need to be handled carefully and stored in a dry place. When a ladder is left secured to a structure during non-working hours, a plank should be tied to rungs to prevent unauthorized access to ladder structure. Certain work should not be attempted using ladders. This includes work here, that is, a secure handhold is not available. Work is at an excessive height where ladder cannot be secured or made stable. Work is of long duration. Work area is very large. Equipment or material to be used are heavy or bulky. Weather conditions are adverse. No protection from passing vehicles. There have been several rumors that work at height regulations have banned use of ladders. This is not true. Ladders may be used for access, and it's legal to work from ladders. Ladders may be used when a risk assessment shows that risk of injury is low and task is of short duration, or there are unalterable features of work site, and that's not reasonably practicable to use potentially safe alternative means of access. More information on ladders, and there we can find requirements of this work at height regulations available from British Ladder. Now there is timber BS 1129 kite mark class 1, industrial aluminum BS 2037 1994 kite mark class 1 industrial, glass fiber BS CN 13111993 kite mark industrial, step stools BS 73771994, step ladders, trestles and staging. Many points discussed for ladders apply to step ladders and trestles, where stability and overreaching are main hazards. Now let us say in case of ladders, what is wrong way and what is right way. You see this picture, this is all wrong here. Step ladder too short, okay. Hazards overhead, okay. Overreaching up and sideways, alright, is not reachable. No grip on ladder, sideways on to work, foot on handrail, and wearing slippers, loose tools on ladder, and slippery and damaged steps. You can see this, slippery and damaged steps, uneven soft ground, and damaged styles, non-slip rubber foot missing. So all these are not acceptable in this case. And you come here, you'll see here, steps at right height, no need to overreach, good grip on handrail, working front on, wearing good flat shoes, clean undamaged steps, firm level base, undamaged styles, rubber non-slip feet all in position, meets British or European standards. All equipment must be checked by supervisor before use to ensure that there are no defects, and must be checked at least weekly whilst in use on site. If a defect is noticed or equipment is damaged, must be taken out of use immediately. Repairs must only be carried out by competent person. Supervisors must also check that equipment is being used correctly and not being used where a safer method should be provided. Where staging such as young man's staging platform being used in roof areas, supervisors must ensure that only experienced operatives are permitted to carry out this work, and that all necessary safety harnesses and anchorage points are provided and used. Main hazards associated with step ladders, tassels, and stagings are unsuitable base, uneven or loose materials, unsafe and incorrect use of equipment, that is, use of staging for barograms, overloading, use of equipment where a safer method should be provided, overhang of boards or staging at supports, trap ends, use of defective equipment. Step ladders and trestles must be manufactured to a recognized industrial specification. Subject to a program of regular inspection, there should be a marking, coding or tagging system to confirm that inspection has happened. Checked by user before use. Taken out of use if damaged and destroyed or repaired. Use on a secure surface and with due regards to ensuring stability at all times. Kept away from overhead cables and similar hazards. Small platform fitted at the top of many step ladders is designed to support tools, paint pots, and other working materials. It should not be used as a working place unless step ladder has been constructed with a suitable handhold above platform. Step ladders must not be used if they are too short for work being undertaken, or if there is not enough space to open them out fully. Platforms based on trestles should be fully boarded, adequately supported, at least one support for each 1.5 meter of board, for standard scaffold boards, and provided with edge protection where when there is a risk of falling a distance liable to cause injury. Fixed scaffolds, it's quicker and easier to use a ladder as a means of access, but it's not always safest. Jobs such as painting, gutter repair, demolition work, or window repairs are often easier done using a scaffold. Unless work can be completed comfortably,
using ladders, scaffolds should be considered. Scaffolds must be capable of supporting building workers, equipment, materials. Now this is a picture of what it says now. Let's start from here. You can see these bases. These are all bases, and these verticals points, then horizontal points, and reveal tie to wedged. So it's there. So we have to consider first these standards, all, and these transoms. You can say these transoms. Then these are ledgers fixed to standards. These are standards, vertical members, and these ledgers to fixed to standards with right angle couplers. And then you can say here on top, all this you can say transom fixed with put log or right angle couplers, and this one standard to other one. Here is bay length, standard to standard, bay length, and there is then you can say, if you see these points here, reveal tie tube wedged into opening with reveal pin and fixed with right angle couplers, joint pin or sleeve couplers, and longitudinal or facade bracing. This is that. And here is 38 by 225 timber sole plates. These are their sole plates standing on soil. And this is ledger bracing. This is ledger bracing at right angles to building. Then guardrails are here, and this is toe board. This is here, toe board, so that the feet is protected. And this is guardrail here, fixed to standards, bay length, and here you can say mid rail. Tools and accumulated waste. A common cause of scaffold collapse is borrowing of boards and tubes from scaffold, thus weakening it. Falls from scaffold are often caused by badly constructed working platforms, inadequate guardrails, or climbing up outside of scaffold. Falls also occur during assembly of dismantling process. There are two basic types of external scaffolds: independent tied and put log. Independent tied are scaffolding structures which are independent of building but tied to it, often using a window or window recess. This is most common form of scaffold. Put log. This form of scaffolding is usually done during construction of a building. A put log is a scaffold. A put log is a scaffold which spans horizontally from scaffold into building. End of tube is flattened and is usually positioned between two brick courses. Put log. Important components of scaffold have been defined in guidance. Standard is an upright tube or pole used as a vertical support in a scaffold. Ledger is a tube spanning horizontally and tying standard longitudinally. Transom, a tube spanning across ledger to tie a scaffold transversely. It may also support a working platform. Transverse, a tube spanning across ledgers, to tie a scaffold transversely. It may also support a working platform. Bracing tube which span diagonally to strengthen and prevent typical independent tied scaffold. B. Fixed scaffold left in place. So this is A here, that is typical independent type. B, fixed scaffold, and this is B. This is fixed scaffold here. Then this is independent scaffold, which is not fixed to build. Horizontal tube fitted to standards along working platform to prevent persons from falling. Though these are fitted at base of working platforms to prevent persons, materials or tools falling from scaffold. Following factors must be addressed if scaffold is being considered for use for construction purposes. Scaffolding must only be erected by competent people who have attended organized training courses. Work carried out on scaffold must be supervised by a competent person. Changes to scaffold must be done by a competent person. Adequate toe board, guide rails, and intermediate rails must be fitted to prevent people or materials from falling. Toe board, guard rails, and intermediate rails. Scaffold must rest on a stable surface. Upright should have a base plate and timbered sole plates if necessary. Scaffolding must have access and egress. Work platform should be fully boarded with no tipping or tripping hazards. Scaffold should be sited away from protected from traffic routes so that it's not damaged by vehicles. Lower level uprights should be prominently marked in red and white strips. Scaffold should be properly braced, secured to building or structure. Overloading of scaffold must be avoided. Public must be protected at all stages of work. Regular inspections of scaffold must be done and recorded. Prefabricated mobile scaffold towers. Mobile scaffold towers are frequently used throughout the industry. Essential that workers are trained in their use, since recent researches have revealed that 75% of lightweight mobile prefabricated towers scaffolding is either erected, used, moved, or dismantled in an unsafe manner. Following points must be considered when mobile scaffold tower to be raised, and let's say this figure. Typical prefabricated tower scaffold. These are having wheels here. Locking wheel is there. Outriggers are there. Outriggers. Cross bracings. This is internal ladder. This portion is ladder, and this portion is outriggers. And keep off from this. You can see ladders here. This is toe boards here, intermediate rails, guard rails, and this is guard rails. Internal ladders, toe boards, cross bracings, outriggers, locking wheels. Following points must be considered when mobile scaffold towers are to be used. Selection, erection, and dismantling of mobile scaffold towers must be undertaken by competent and trained persons, with maximum height to base ratio not being exceeded. Diagonal bracing and stabilizers should also be used. Access ladders must fit to narrowest side of tower or inside tower, and persons should not climb up frame of tower. All wheels must be locked while work is in progress, and all persons must vacate tower before it is moved. Tower working platform must be boarded, fitted with guardrails and toe boards, and not overloaded. Towers must be tied to a rigid structure if exposed to wind, weather, or to be used for work such as jet blasting. Persons working from a tower must not overreach or use ladders from work platform. Safe distances must be maintained between tower and overhead power lines, both during work operations and when tower is moved. Tower should be inspected on a regular basis and a report made. Mobile elevated work platforms. Mobile elevated work platforms. Mobile elevated work platforms are very suitable for high level work such as changing light bulbs. Changing light bulbs in warehouse. Following factors must be considered when using mobile elevated work platforms. Mobile elevated work platforms must only be operated by trained and competent persons, must never be moved in elevated position, operated on level and stable ground, with consideration being given for stability and loading of floors. Tires must be properly inflated and wheel immobilized. Outriggers should be fully extended and locked in position. Due care must be exercised with overhead power supplies, obstructions, and adverse weather conditions. Warning signs should be displayed and barriers type wide range the tires kind of lift a hoist. That's what we say mobile towering elevator platform. It should be maintained regularly and procedures should be in place in event of machine failure, and drivers of mobile elevated work platform must be instructed in emergency procedures, particularly to cover instances of power failure. When working on such platform, there is a danger that operator may become trapped against an overhead or adjacent object and preventing him from releasing controls. There have also been accidents caused when such tower reversed into areas where there is poor pedestrian segregation and driver has limited visibility. During a maneuvering operation, a dedicated van should be used. Inspection and maintenance. Inspection. Equipment for work at height needs regular inspection to ensure that it is fit for use. A marking system is probably required to show when next inspection is due. Formal inspection should not be a substitute for whatever pre-use checks or routine maintenance. Inspection doesn't necessarily cover checks that are made during maintenance, although there may be some common features. Inspection need be recorded but checks do not. Under work at height regulations, weekly inspections are still required. For scaffolding used in construction as required by construction design and management organization regulations, where a person could fall 2 meters or more. The requirement for inspections are set out into regulations. Name and address of person for whom inspection was carried out, location of work equipment inspected, description of work equipment inspected, date and time of inspection, details of whatever matter identified that could give rise to a risk to health or safety of any person. Details of whatever action taken as a result of whatever matter identified in paragraph 5. Details of whatever further actions considered necessary, name and position of person making report. Now, this appendix shows the inspection format under CDM regulations, which still covers essential items. Work under work at height regulations has been slightly adapted to suit maintenance. Inspections and even thorough examinations are not substitutes for properly maintaining equipment. Information gained in maintenance work inspections or thorough technical examination should inform one another. Maintenance logs should be kept and be up to date. Whole maintenance system shall require proper management system. Frequency shall depend on equipment, condition in which it is used, and manufacturer's instructions. Excavations. Hazards associated with excavations. Now we are coming to construction. There are about 7 deaths each year due to work in excavations. Many types of soils such as clays are self-supporting, but others such as sands and gravel are not. Many excavations collapse without whatever warning is required, resulting in death or serious injury. Many such accidents occur in shallow workings. It's important to note that although most of these accidents affect workers, members of public can also be injured. Specific hazards associated with excavations are as follows. Collapse of sites, materials falling on workers in excavation. Collapse of sites, materials falling on workers in excavation, falls of people and of vehicles into excavation, workers being struck by plant, specialist equipment such as pneumatic drills, hazardous substances, particularly near site of current or former industrial processes, influx of ground or surface water and entrapment of silt or mud, proximity of stored materials, waste materials or plant, proximity of adjacent buildings or with ladder access. With ladder access and supported services, guard removed on one side for clarity. So, there is shuttering, polling board, these are wedges, walling, wheeling, cross one, wedges, wheeling, and this is puncheons, and these are supports. This is ladder, this is rail. Screw props or studs. Underground services, access and egress to excavation, fumes, lack of oxygen, and other hazards such as Wells disease. Clearly, alongside these specific hazards, more general hazards such as manual handling, electricity, noise, and vibrations shall also be present. Precautions and controls required for excavation. Following the precautions and controls should be adopted. Going back in 5 minutes. Just opening doors, coming, take some water and coming back. we can say that at all stages of excavation, a competent person must supervise work, and workers given clear instructions on working safety in excavation. Sites of excavation must be prevented from collapsing, either by digging them, excavating them at safe angle between 5 and 45 degrees dependent on soil and dry state of soil, or by shoring them up with timber, sheeting, or a proprietary support system. Falls of material into workings can also be prevented by not storing spoiled material near top of excavation. Falls of materials into workings can also be prevented by not storing spoiled material near top of excavation. Workers should wear hard hats. If excavation is more than 2 meters deep, a substantial barrier consisting of guardrails and toe boards should be provided around surface of workings. Vehicles should be kept away as far as possible using warning signs and barriers. Where a vehicle is tipping materials into excavation, stop blocks should be placed behind its wheels. It's very important that excavation site is well lit at night. All plant and equipment operators must be competent, and non-operators should be kept away from moving plants. Personal protective equipment must be worn by operators of noisy plant. Nearby structures and buildings may need be shored up if excavation may reduce their stability. Scaffolding could also be destabilized by adjacent excavation trenches. Influx of water can only be controlled by use of pumps after water has been channeled into sumps. Risk of flooding can be reduced by isolation of mains water supply. Presence of hazardous substances or health hazards should become apparent during original survey work, and when possible, removed or suitable control measures adopted. Such hazards found after work has started that must be reported and noted in inspection report and remedial measures taken. Exhaust fumes can be dangerous, and petrol or diesel plant should not be sited near top of excavation. Presence of buried services is one of biggest hazards, and position of such services must be ascertained using all available service location drawings before work commences. Since these shall probably not be accurate, service location equipment should be used by specially trained people. Only hand tools should be used in vicinity of underground services. Overhead services may also present risks to cranes and other tall equipment. Safe access by ladders is essential, as are crossing points for pedestrians and vehicles. Whenever possible, workings should be completely covered outside working hours, particularly if there is a possibility of children at entering site. Finally, care is needed during filling in process. Inspection and reporting requirement. Duty to inspect and prepare a report. Duty to inspect and prepare a report only applies to excavations which need be supported to prevent accidental fall or materials. Only persons with recognized and relevant competence should carry out an inspection and write report. Inspection should happen at following timings and frequency. After event likely to affect strength or stability of excavation, before work at start of every shift, after an accidental fall of whatever material. Although inspection must be made at start of every shift, only one report is required of such inspections, even every 7 days. However, reports must be completed following all other inspections. A report should be completed before end of relevant working period and a copy given to leader responsible for excavation within 24 hours. A report must be kept on site until work is completed and then retained for 3 months at office of organization which carried out work. A suitable form is shown in appendix. Now, practical negotiable questions. So, outline a hierarchy of measures to be considered when a construction worker is likely to fall while working at height. Outline 8 precautions that should be considered to prevent accidents to children who might be tempted to gain access to construction site. A contractor has been engaged to undertake building maintenance work in a busy warehouse. Outline issues that should be covered in induction program for contractors' employees. Exterior paintwork of a row of shops in a busy high street is due to be repainted. Identify hazards associated with work and outline corresponding precautions to be taken. Outline precautions to be taken when carrying out repairs to flat roof of a building. Outline precautions to be carried. Outline precautions to be taken when repair work is to be carried out on sloping roof of a building. Outline precautions to be taken on ensure safety of workers required to undertake repair work of a fragile roof. Explain meaning of term hazard. Outline main hazards that may be present during demolition of a multi-story building. Outline possible causes of dumper truck overturn on construction site. Identify design features of dumper truck intended to minimize risk of severity of injury from an overturn. A manufacturing company is to relocate to premises that require refurbishment before equipment and staff can be moved. Outline sanitary and washing facilities that should be considered when planning refurbishment. Outline health and safety requirements relating to provisions of welfare, fire prevention and first aid facilities on construction sites. Outline main duties of CDM coordinator under construction, design and management regulations. Identify 4 items of information in health and safety file for an existing building that might be needed by a contractor carrying out refurbishment work. With reference to construction, design and maintenance management regulations, identify circumstances under which a construction project must be notified to the enforcing authority. So these are certain questions answers which you can go or we can, because go through that pages only if you can. Okay, this is that one. We have gone through this. Then it is identified 4 possible ill health. I think 8 possible hazards. 8 what? Item 3 statutory restrictions. All right. It's It was here, I think. Okay. With reference to construction design and management regulations, identify circumstances under which a construction project must be notified to an enforcing authority. Outline duties of client under regulations. Outline 4 duties of each of following persons under construction design mentioned: the CDM coordinators, principal, the contractor. Explain use issue that would need to be addressed if work is to be carried out safely from a ladder. Main dangers and corresponding precautions that should be taken with use of ladders. Identify ways in which accident may be prevented when using ladders as a means of access. Outlines precautions that might be taken in order to reduce risk of injury when using ladders. 3 cases of a scaffolding collapse. Mobile tower scaffold should be used on stable, level ground. 8. List 8 additional points that should be considered to ensure safe use of a mobile tower scaffold. Identify measures that should be adopted in order to protect against dangers of people and or materials falling from mobile tower scaffold. Give reasons that may cause a mobile tower scaffold to become unstable. Outline precautions to be taken when using a mobile elevating platform to reach a high point such as street light. Fluorescent tube in roof space of a busy warehouse are to be replaced by maintenance workers using a mobile elevating working platform. And identify potential hazards associated with task. Outline measures to be taken to ensure the safety of maintenance workers and others who may be affected by works. Identify main hazards associated with excavation work on construction sites. Main precautions to be taken when carrying out construction work. Water main supplying a school is to be replaced. Work shall be carried out at 1.5 meter deep excavation, which shall be supported in order to ensure safety of employees working in excavation. Identify when 3 statutory inspections of supported excavation must be carried out by competent person. State the information that should be recorded in excavation inspection report. Other that provisions of support for excavation. Outline additional precautions to be taken during repair work in order to reduce risk of injury to employees and others who may be affected by work. Identify 8 possible health hazards to which construction workers may be exposed and in each case give an example of a likely source. Identify 4 possible ill health effects that can be caused from working with cement. Outline ways in which ill health effects can be prevented. Identify 3 types of asbestos commonly found in building. Explain where asbestos is likely to be encountered in a building during renovation work. Inspection report. A report of result of every inspection made in pursuance of construction, design and management. Regulation 2007 or work at height Regulation 2005. Name and address of person for whom inspection was carried out. Site address, date and time of inspection, location and description of workplace, including plant, equipment or materials inspected, matters which give rise to health and safety risk. Can work be carried out safely? If not, name of person informed, details of work, the other action taken as a result of matter identified above, details of further action considered necessary, name and position of person making report, date report handed over. Then inspection reports notes says that timings and frequency of inspections, place of work requiring inspection before being used for first time, after substantial addition, dismantling or alteration, after event likely to have affected its strength or stability, or at regular intervals, not 7 days, 7 days before work, at start of every shift, after accidental fall of rock, earth or any material. Working platform, any working platform or part thereof, personal super suspension equipment, to fill in all this. Excavations which are supported in pursuit of paragraphs 1 to 3 of Regulation 12 of Construction. To this, cofferdams and caissons. General, let's say, Notes. General. Inspection report should be completed before end of relevant working period. Person who prepares report should within 24 hours provide either report or copy to person on whose behalf inspection was conducted or carried out. Person who prepares report should within 24 hours provide either report to company or person on whose behalf the report was carried out. Report should be kept on site until work is completed, should then be and retained for 3 months at an office of person for whom the inspection was carried out. Working platforms only. Inspection is only required where a person is liable to fall more than 2 meters from place of work. Employer or other person who controls activities of persons using a scaffold shall ensure that it is stable and of sound construction and that relevant safeguards are in place before employees of person under control first use scaffold. No report is required following inspection of mobile tower scaffold which remains in same place for less than 7 days. Where an inspection of working platform or part thereof in personal suspension is carried out before it is taken into use for first time, after substantial addition, dismantling or other alteration, not more than one report is required for every 24 hours period. Where an inspection of a working platform or part thereof in personal suspension equipment is carried out before it is taken into use for first time, after substantial addition, dismantling or other alteration, not more than one report is required for whatever any of the was. Excavations only. Duties to inspect and prepare report apply only to extension which needs to be supported to prevent person from trapped or buried by an accidental collapse, fall or dislodgement of material from its sides, roof or area adjacent to it. Although an excavation must be inspected at the start of every shift, only one report of such inspections is required every 7 days. The report must be completed for all inspections carried out during this period for other purposes, namely after accidental falls of materials. Health and safety work, and this is a form here, it says checklist of typical scaffolding faults. This is checklist here. You can see I can rotate it better. This is checklist. Footings, soft footings, standard ledgers, bracings, putlocks and transoms, couplings, bridles, ties, boarding, guardrails and toe boards, ladders. So footings soft and uneven, no base plates, no sole plates, undermined, standards not plumbed, jointed at same height, wrong spacing, damaged ladders, not level, joints in same way, loose, damaged, bracings, some missing, loose, wrong way. Footlocks and transoms wrongly spaced, loose, wrongly supported, couplings wrong, fitting loose, damaged, not checked couplers, bridles wrong spacing, wrong couplings, no check couplers, ties some missing, loose, not enough, boarding, bad boards, trap boards, incomplete, insufficient supports, guardrails and toe boards, wrong rise, loose, some missing, ladders damaged, insufficient length, not tied. And here we can go back to, you can say, now here this is summary of proposed application and notification under CDM 2007. This person says I need some construction work done. It says you can get it quicker and cheaper than that. Okay, other says shortcut always, cost more and take longer in end. Think thorough. So this is just likely to notify. This is a process, you can say, not necessarily applies to you, but you can go through this and find it. Just a craft. Pre-construction information. This is England actually. It's taken from appendix of ACOP Managing Health and Safety when drawing up pre-construction information. Each of following topics should be considered. Information should be included where topics is relevant to work proposed. Pre-construction information provides the information for those bidding for planning work and for development of construction phase plan. Level of detail in risk information should be proportionate to risk involved in project. Pre-construction information. Description of project. Project description and program details, including key dates, including planned start and finish of construction phase, and finish of construction phase, and minimum time to be allowed between appointment of principal contractor and instruction to commence work on site. Details of client, designers, CDM, coordinator and other consultants. Whether or not structure shall be used as a workplace, in which case finished design shall need to take account of relevant requirements of workplace, health, safety and welfare regulations, extent and location of existing records and plans, client's considerations and management requirements. Arrangements for planning for and managing construction work, including any health and safety goals for project, communications and liaison between clients and others, security of site, welfare provisions, requirements relating to health and safety of clients, employees or customers or those involved in project, such as site hoarding requirements, site transport arrangements or vehicle movement restrictions. Procedures and means of escape, no-go areas or other authorizations requirements for those involved in project, areas client has designated as confined spaces, smoking and parking restrictions, environmental restrictions and existing on-site risks, safety hazards including boundaries and access, including temporary access, namely narrow streets, lack of parking, turning or storage, restrictions on deliveries or waste collection or storage, adjacent land use, namely schools, railway lines or busy roads, existing storage of hazardous materials, location of existing services, particularly those that are concealed, water, electricity, gas, etc. Ground conditions, underground structures of water courses, where this might affect safe use of plants, cranes or safety of groundwork. Information about existing structures. Information about existing structures. Stability, structural form, fragile or hazardous materials, anchorage points for fall arrest systems, particularly where demolition is involved. Previous structural modifications, including weakening or strengthening of structure, particularly where demolition is involved. Fire damage, ground shrinkage, movement or poor maintenance, which may have adversely affected structure. Difficulties relating to plant and equipment in premises, such as overhead gantries whose height restricts access. Health and safety information contained in earlier design, construction or as-built drawings, such as details of pre-stress or post-tension structure. Health hazard including asbestos, including results of surveys, particularly where demolition is involved. Existing stores of hazardous material, contaminated land, including results of surveys, Existing structures containing hazardous materials, health risks arising from clients' activities, significant design and construction hazards, significant design assumptions and suggestions of methods, sequences of other control measures, arrangements for coordination, arrangements for coordination of ongoing design work and handling design changes, information on significant risks identified during design, materials requiring particular precautions, health and safety file, description of its format and in conditions related to its content. Now, when drawing up construction phase plan, employers should consider each of following topics. Information should be included in plan where topic is relevant to work proposed. Plan sets out how health and safety is to be managed, organized during construction phase. Level of detail should be proportionate to risks involved on project. Construction phase plan. Description of project. Project description and program details including key dates, details of client, CDM coordinator, designers, principal contractor and other consultants. Extent and location of existing records and plans that are relevant to health and safety on site, including information about existing structures when appropriate. Management of work. Management structure and responsibilities, health and safety goals for project and arrangements for monitoring and review of health and safety performance, arrangements for regular liaisons between parties on site, consultations with workforce, exchange of design information between client, designers, CDM, coordinator and contractors on site, handling design changes during project, selection and control of contractors, exchange of health and safety information between contractors, site security, site induction, on-site training, welfare facilities and first aid, reporting and investigation of accidents and incidents including near misses, production and approval of risk assessments and written statements, systems of work, site rules, fire and emergency arrangement. Arrangements for controlling significant site risk, safety risks including delivery and removal of materials, including waste and work equipment, taking account of risks to public, namely during access to and egress from site, dealing with services, water, electricity and gas, including overhead power lines and temporary electrical installations, accommodating adjacent land use, stability of structures whilst carrying out construction work, including temporary structures and existing unstable structures, preventing falls, work with or near fragile materials, control of lifting operations, maintenance of plant and equipment, work on excavations and work where there are poor ground conditions, work on wells, underground earthwork and tunnels, work on or near water where there is risk of drowning, work involving diving, work in a caisson or compressed air working, work involving explosives, traffic routes and segregation of vehicles and pedestrians, storage of materials, particularly hazardous materials, and work equipment and other significant safety tasks. Health risk including removal of asbestos, dealing with contaminated land, manual handling, use of hazardous substances, particularly when there is a need for health monitoring, reducing noise and vibration, working with ionizing radiation, other significant health risks, health and safety file, layout and format, arrangements for collation and gathering of information, storage of information. I think that's the end of this file. You can see these pages we discussed. We discuss here, you can see the scope of construction, construction hazards and controls, safe place of work, and likewise work at height, and you can say secure site, various chapters like this, pages, fragile roofs and surfaces, demolition. Likewise we did so many. Likewise you can see now what was actually tracing general records. Here we have hazards control we were talking, and that's what we had to go into this. So we'll take up this file of hazards control now and see what we have done here. Now this procedure is applicable to all projects concerned site activities. We are discussing about this, but I had to refer to that chapter, that page from some unknown source. Now purpose is to establish a procedure for systematically identifying hazards risks. Systematically identifying all hazards risks associated with a task or job, and to implement appropriate required control measures. This study is applicable to all activities involved on project, including temporary works, preparatory works, permanent works, handling works, producible or deliverable works such as deep excavations, civil buildings, erection, piping, electrical, mechanical, heat ventilation and air conditioning, external works, interconnections, processing areas, non-processing areas, indoor areas, etc. So we read it. What's the purpose of a scope? The scope is that it applies to projects, construction site activities, and purpose is A, establish a procedure for systematically identifying all hazards risks that are expected and associated with a task or job, and to implement appropriate required control measures. And this study is applicable to all activities involved in project, including temporary works, preparatory works, permanent works, handling works, producible or deliverable works such as deep excavation, then civil buildings, erection, piping, electrical, mechanical, heat ventilation and air conditioning, external works, interconnections, processing areas, non-processing areas, indoor areas, activities. Now here is temporary work. What is temporary work? Like scaffolding, like ladder, it's all temporary work. Preparatory works means formwork system, formwork, ply, battens, rails, that's preparatory work. Then permanent works, concrete, steel fixing, handling works are producible, etc. Deliverable works is a deep excavation, civil well. Handling works producible or deliverable works such as deep excavation, civil building, etc. Now these are same definitions. Safety means safety, health and environments, disciplines to support project activities, and company means organization carrying out prosecuting project. Contractor means organization that's one project from owner, client. Subcontractor means organization that's one part of project work from contract organization. Client means an organization entitled company in contractual terms that is entrusted for project to organization of a contractor. Client means an organization entitled company in contractual terms that has an entrusted project organization of contractor. Personnel means all personnel involved in project site activities belonging to all companies, organizations, contractors of contract. All responsibilities means job and contract responsibilities. Responsibility means job and contract responsibility. Training means training imparted for specific safety topic on job on project site. Management organization means organization top, middle and lower management. Safety leader, safety manager means a person with job title, safety leads, safety personnel means all personnel involved in project sites belonging to all organizations, including contractors, subcontractors, suppliers, and owner, or whoever else directly or indirectly involves. Responsibility means job and contract responsibility, and whatever conditions are given on contract, maybe in general conditions or specific conditions, project conditions, all come under responsibility and obligation and distribution of responsibility. You can say it should be shown on distribution, DOR, distribution of responsibility matrix. Training means training imparted for specific safety topic on job or project site. There is always safety officer available everywhere on site, and that job is to train them, all people including staff and workers, about safety. Management organization means organization top, middle and lower management. And top you can say project leader and project director and all that, and middle are all managers and officers, and lower managers, frontline workers. Safety lead means a person with job title safety leader, safety manager deployed by certain organizations, an expert on safety topics. Project manager means a person as such a project title deployed by contractor who is an engineer, who can be a manager, and who has title of project manager. Project manager means a person such with PM title deployed by contractor. And engineer means a person appointed by client company. Engineer means a person appointed by client or client company for overall proper project responsibility of administration and execution. Project engineer employee, owner engineer. Project engineer employer, owner. Safety task analysis, risk reduction talk. Start is called safety task analysis, risk reduction talk. We have to reduce risk to much below level where it works safe, it doesn't harm our worker. Safety task analysis, risk reduction talk. A process that utilizes employees personnel to identify and resolve environmental, safety and health hazards associated with a task prior to its being performed. Job hazard analysis. Identifies key job steps, tools, equipment, potential environmental safety and health hazards, hazard controls practices, required personal protection equipment for larger, more complex and usually repetitive jobs. It's prepared by a team normally consisting of a representative from environmental, safety and health department, employee supervisors and field engineering representatives. Task activity. A specific activity or part of a job, that is installation a pipe hanger, building a concrete form, or installing electrical power to fabrication areas. Task activity, a specific activity or subpart of a job, that is installing a pipe hanger, building a concrete form, or installing electrical power to a fabrication area. Hazard control sheets, a series of risk assessment sheets used for S. Then hazard control sheets, a series of risk assessment sheets used for assisting line supervisors in developing start JHA process. Task activity, specific activity of subpart of a job, that is installing a pipe hanger, building a concrete form, or installing electrical power to a fabrication area. Responsibilities, in general respecting certain contract positions. Project manager responsible for overall obligations to provide schedule, all resources, directions, engineering solutions. Project manager or project leader, you can say, who is responsible for overall project in terms of contract, is defined in contract document itself. What is project runner or project manager? It's difficult to find. It's difficult to find sometimes, no. Project manager's duty to do everything, to provide all resources in material terms, in resources, in human resources term, or in improving education terms. Then you can say site project manager, who arranges, who is responsible for budget control, who is responsible for deciding about resources, has a large number of duties, not only resources duties but also technical duties and managerial organizational duties, responsible for project, spokesman of project. Site leader responsible for overall site prosecution, management, site safety officer, a site manager responsible for overall site prosecution, management over works and subcontractors, delegated responsibility of site leader responsible for overall site prosecution, management over site manager responsible for overall site prosecution, management over works and subcontractors, that is supervise all activities, and there's a problem for resources, something that raise requisitions to project responsible. Site safety officer responsible for overall safety organization on site and reports to project leader, site leader, corporate safety leader. Site safety officer is very responsible as far as details runnings are concerned, details inspections are concerned, site visits are concerned. I think he should be very technically strong as far as construction is concerned, because that person has to deal with his senior engineers, its site in charges. That person has to look after that. So site safety officer responsible for overall safety management on site and report to project manager, site manager, safety manager, and he has to make sure that toolbox talks are conducted. Every worker knows how to do a safe job and what methods are required to make requisitions of that, and to keep a watch on lapses. Manager, site leader, corporate okay. Construction leader responsible to arrange all safety related resources and provide site team all requirements. This construction person is same as project construction manager or project site manager is there. But there is variation that soil may, you can say soil may be affected, and then all matters will be affected. Construction manager has to take care of that, and also all materials must be available in time, safety related, before it's required. Therefore, its cost of procedure, cost of liaison to get information from site based on. So we can see that here. This job of construction leader, then project site leader, site engineer you can say. This is detailed runner in front always to lead work team. This engineer responsible, project site engineer responsible to carry out safely all activities, whatever work to be done, to make sure that all items in guessing and safe. Then you can say project site engineer responsible to carry out safety work within section. All works to make sure before somebody tells him you are not doing this. Site safety inspector, engineer responsible to supervise safety measures on site and control safety issues, should bring to site line management to adopt correct measures. So we can say site safety engineer is that was responsible for arranging all details to deal with safety officer, and safety officer has to deal with site engineer for coordination purpose, and that meeting should be attended and decision should be taken, because safety is first requirement of work, or else you can't start work. And if site engineer delays these items, safety person can stop work. Safety inspector, engineer responsible to supervise safety measures on site and control safety issues, should bring to site line management or forward organization to adopt correct measures because it's duty. And you can say site safety inspector engineer responsible to supervise safety measures on site and control safety issues should bring to site line organization to adopt correct measures, and site foreman responsible for compliance of safety measures as standards or as directed. Then we can say that site foreman responsible for compliance of safety measures as standards or as directed. An individual working on site responsible to maintain safety measures in case missing should bring to site team instruction attention because safety is a responsibility of each and every one. Each and every one person, safety is responsible for all. Now responsibilities. Ensure that I put this on. I think I should put on this. Site leader responsibility for what? Ensure that his procedure is being applied for control of all activities through EPC contractor, supervision and subcontractor organization. Of course, it's duty, site worker. Health, safety and environment supervisor, manager, leader, responsible for development of this procedure and monitoring compliance. Site leader, civil or other discipline contractor shall ensure that sufficient resources are provided to implement this procedure and that procedure is understood as well as applied in conformities. Site superintendent, supervisor and subcontractor shall be thoroughly familiar with this procedure on their individual responsibilities regarding implementation and enforcement. Shall carry out regular inspections daily within their work areas to ensure that requirements under this procedure are being followed. Instructions, guidelines for start. Subcontractor supervision shall ensure employees' involvement with start. So we can say guides for start. We can say guides for start because here superintendent has full responsibility. We'll say subcontractor supervision shall ensure employers' involvement with start process by ensure that employees under control are trained in start process, establishing a system to follow up with all crews to verify start process being correctly implemented. Requiring employees to participate with individual start review prior to start of each shift for each new work. with an individual start review prior to start of each shift for each new task, requiring employees to participate with an individual start review prior to start of each shift for each new task. Supervisors shall discuss hazards relating to project facility. Supervisors shall discuss hazards relating to project facility with employees to compile information necessary to complete start card. Upon completion of start card, supervisors shall review requirements of card with employees performing work and supervisors sign card. Cards shall be translated into common workers' language and displayed for review within immediate work area. Start cards are to be returned to supervisor and forwarded to contractor safety supervisor's office as appropriate at end of each shift or completion of work activity. Supervisor responsible is responsible for ensuring that cards are properly completed, signed and returned. Start cards should be reviewed for proper uses, completion by health, safety and environment. You can say start cards should be reviewed for proper uses, completion by health, safety and environment supervisor and record on file in Contact HSC office. Guidelines for job hazard analysis. Job hazard analysis. Job hazard analysis or assessment may be included as part of work plan, work package. Requirements of job hazard analysis or assessment may be incorporated into hazardous work permits HWP as well as project facility specific HSE plans as appropriate. Job hazard analysis of specific jobs or operations is required for but not limited to following only: high risk jobs, new jobs or tasks that present unspecified or unknown hazards, jobs or tasks involving new equipment, machinery or procedures, major job categories that shall be repeated frequently, jobs or tasks that have historically experienced a repeated or significant rate of accidents, injuries, exposures or near misses, jobs involving environmental remedy of hazardous waste, jobs or tasks that in professional judgment of responsible HSC SHE representative require a formal job hazard analysis. Jobs or tasks are broken down into a series of successive steps or activities. Required or anticipated tools and equipment for each step or activities are to be included. Jobs or tasks are broken down into a series of successive steps or activities. Required or anticipated tools and equipment for each step or activity are to be included. All potential hazards within each step or activity are identified, include following hazards categories in job hazard. Chemical exposures. Chemical exposures, oxygen deficiency, exposure to ionizing and non-ionizing radiations, electrical hazards, physical hazards, fire and explosion, temperature extremes, excessive noise, biological hazards. Chemical exposure, oxygen deficiency, exposure to ionizing and non-ionizing radiations, electrical hazards, physical hazards, fire and explosion, temperature extremes, excessive noise, biological hazards. Input should be solicited from multidisciplinary professional staff for hazard evaluation. This input should include safety, industrial hygiene, physics and engineering personnel. This input should include safety, industrial hygiene, health physics, and engineering personnel. After all known suspected or potential hazards have been identified and accident experiences reviewed, a plan must be developed giving solutions to eliminate further or control hazards. Elimination or control of hazards should be implemented first by engineering methods and then by administrative methods, and at least by proper use of personal protective equipment PPE. Guidelines for using hazard control sheets. Hazard control sheets applicable to a work activity shall be used as a reference on developing a start card or a specific job hazard analysis. In circumstances where a start card or GHA are not deemed necessary, hazards control sheet may be used as a guideline to guidelines for hazards control sheets. Hazard control sheets applicable to work activity shall be used as a reference on developing a start card or a specific job hazard analysis. In circumstances where start card job not deemed necessary, the hazards control sheet may be used as a guideline for conducting a task team talk by supervision to respective employees. BSHE procedures, attachment start card, job hazard analysis, and control program sheets. Here is attachment 7.1, safety task analysis, risk reduction talk. This abbreviations full form. That is safety task analysis, risk reduction talk, start card. Safety task analysis, risk reduction talk. In this, what we do, let us say, let's reduce this a little. That is a supervisor, date, job description, primary hazard risks, location. Electrical item, we are yes, no, not applicable. In electrical item, locked and tagged, you have to write yes or no or not applicable. Try and test, disconnected. So locked and tagged, try and test, disconnected. In excavation, showed, battered. Excavation is showed, battered. Ladder provided. In daily inspection, entry permits. Yes, no, not applicable. Then body, hazards body, fall potential, pinch points, electrical shock, housekeeping. And slip trip, flying particles, thermal burns, manual lifting. Out of this you have to see slips. You can say slip trip, flying particles, thermal burns, manual lifting, sharp objects, and in permits, hot work, confined spaces, braking process, excavation, critical lift plan, personal basket. Emergency equipment, fire extinguisher, safety shower, eye wash, permit displayed, all conditions met, evacuation, assembly area. Fire extinguisher, safety shower, eye wash, permit displayed, all conditions met, evacuation, assembly area. Hazards environmental, airborne particles, vapors, hot cold surfaces, hot cold materials, noise, heat stress. Proper equipment, man lift, personal basket, forklift, JLG lift, crane, chain fall, hand tools, powered tools, good conditions, operator certificate, proper rigging, current inspection, trucks, tractors, etc. These are various. Again, man lift, personal basket, forklift, JLG lift, crane, chain fall, hand tools, power tools, good conditions, operator certificate, proper rigging, current inspection, trucks, tractors, etc. Overall, overhead work or floor opening. Overhead work or floor opening. Fixed barricades, tape danger. Overhead, fixed barricades, tape danger, tape caution, barriers, signs, hole cover, cleat, handrails, toe boards. Process equipment. Process equipment, valves locked, tags hung, blinds installed and tagged, proofed. Standby persons, confined space, fire watch, sandblast person, traffic watch, welding. Shields, welding. Welding shields, what shield about shields, you can say. Shields, fire blanket, shield, fire blanket, fire extinguisher, shield, fire blanket, fire extinguisher, cylinder secured, combustibles, moved sparks contained, hazards, chemicals. MSDS reviewed revealed chemical burn, skin, eye irritant, inhalation, personal protective equipment, work gloves, chemical gloves, anti-vibration gloves, wet suits, foot guards, rubber boots, mono goggles, face shield, fresh air, ear protection, safety harness, burning goggles, hard hat, safety glasses, respirator, others. Let us repeat, it's important. Work glass, PP I am talking, personal protective equipment. Work gloves, chemical gloves, anti-vibration gloves. So there are three types: work gloves, chemical gloves, anti-vibration gloves. Wet suits, foot guards, rubber boots, mono goggles, face shield, fresh air, ear protection, safety harness, burning goggles, hard hat, safety glasses, respirators, others. So when you say rubber boots for concrete, work gloves for all work, chemical gloves for chemical work when you apply construction chemical, work gloves and work, anti-vibration use of the grinders or machines, something like that. Wet suits and rain. Foot guards means so that your fingers are not impacted upon. Rubber boots for concrete, mono goggles and face shield. You can say fresh air, oxygen or fresh air, ear protection, safety harness, full body safety harness, ear protection, and burning goggles and hard hats, helmets, safety glasses, respirators and others. Important one. Well, I think there's so many in this. We'll take later on all. Now we can say that there are so many. We have forms here after all. We can say these are all forms we'll see. We'll take different levels of these files later. Now we are going to close this at this moment. We have gone through this list and we close it now for time being because it's already more than 3 hours. And we have to take care of many other activities as well. We can say I would say we have taken, meanwhile we can say that here we have gone through this and we have gone also through this, that is our this as you can see. And of course quality talk which we did here, in this case quality talk, and this all we have gone through. Very long chapter it was which we have gone through this. This is by whom it was? 16th chapter of some book. Let's have a review. We'll be done with this. It's just a revision, a review of pages and scanning.
So it is here, but and I'm not the risk of closing this. I think I should thank you very much for this now, right? I'm thankful to this. I close it now.